Good day, students. In this clip, we're going to be doing some review problems on conics and quadratics. All right, for our question number one, is a question on conics. We are to write the equation of a circle with a center at 3, -2, and a radius of 6. All right. So the center radius form of the equation of a circle can be given by x minus h quantity squared plus y minus k quantity squared equals r squared. Okay? Equals the radius squared. All right, so in order for us to write the equation of a circle in the center radius form, all we need are the coordinates of the center, h and k, and the radius. So the problem provides us with the center and the radius, so we can clearly see that h is 3, k is -2, and r is 6. Okay, so we're going to substitute these values into the center radius form of the equation of a circle. Okay, so if we make a substitution, we're going to have x minus 3 quantity squared plus y minus, and you have to be careful here because k is negative, so you have to preserve that negativity of the value of k, square equals radius, which is 6 square. All right, let's simplify this quantity here. So we are going to have x minus 3 quantity square plus y plus 2 square equals 6 square, which is 36. Okay, so this is the equation of a circle with center 3, -2, and a radius of 6. All right, let's take a look at question number 2. This is also another question on conics. So for question 2, we are to write the equation, in standard form. And the equation is 36x squared plus y squared minus 2y minus 35 equals 0. Okay, so this form we have right here is the general form of the equation of a conic. And we know what conic this is. You notice we have two squares, so it's either a hyperbola, a circle, or an ellipse. But since there's a plus between the two squares, we know that this is automatically a circle or an ellipse. Now, since the coefficient of the squares are different, this must be an ellipse. All right, so we know what the general form, the standard form of the equation of an ellipse is x minus h squared over a squared plus y minus k squared over b squared equals 1. So this is our target, this is our goal. This is the form we want to convert this general form into. Okay, so this form right here is general form, and then this form we have right here is the standard form. All right, so let's go ahead and proceed. What we're going to do is we're going to separate the x's and the y's. So 36x squared is the only term with the x associated with it. And then we have y squared minus 2y. Now 35 is neither an x nor a y, so we're going to add 35 to both sides of the equation. Okay, so this will be equal to 35. Now let's divvy down the center, and then we're going to factor by grouping. Okay, so let's divvy down center like this. Now this is already a perfect square, so we can express the variables in the y world as 36 times x minus 0 quantity square. Now, in the y world, we have an incomplete square, so we have to complete the square. All right? So we have y squared minus 2y. Now we have to add a term that makes this a perfect square trinomial. Okay? In order not to change the problem, when we add it to the right side of the equation, we must add exactly the same thing to the left side of the equation. All right? So what are we going to add? Well, we're going to complete the square. Remember, you use b over 2 square to complete the square. B in the y world is negative 2. If we divide that by 2, we get negative 1. When we square it, we get 1. Okay? So we add 1 here and add 1 here. And then now we can factor it. This stays the same. To factor this perfect square trinomial, we just root the first and the last term and bring down the middle sign, okay? So we'll have plus y minus 1 quantity square equals 36. Now to finish this off, we have to have this equation equal to 1, as we can see here. So to accomplish that, we have to divide every term in this equation by 36, okay? Whatever the numerical value on the right side of the equation is, that's what we're going to divide every term in the equation by. All right, so now let's see what that yields. We're going to have x minus 0 quantity square plus, because these two 36's here, they divide out. 36 goes here 1, 36 goes there 1, plus y minus 1 quantity square over 36. 36 over 36 is 1. Okay? So this is the standard form of the equation of the ellipse. So standard form. So that's that. Let's go ahead and box our answer. All right, the next few questions we're going to look at have to do with quadratics. Problem number 3. When the equation x squared plus 4x equals 11 is being solved by completing the square. Completing the square. Which expression represents the completed square? So write an expression for the completed square. All right, so obviously we have an incomplete square here, x squared plus 4x equals 11. Now to complete this square, we're going to do what we did in the previous problem. X squared plus 4x plus a term that makes the left side a perfect square trinomial. Now, since we're adding 11 to the left side, in order to preserve equality, we must add exactly the same number to the right side. Okay? All right, so now to complete the square, remember it's b over 2 square. In this case, b is 4 because you have a, b is the coefficient of x, and c is what completes the square. So we are going to divide it by 2. Remember, it's b over 2, which is 2, and then we're going to square that. B over 2 squared is 4. Okay, so we're going to add 4 to both sides. On the left side, we have a perfect square trinomial, and then we factor it through the first and the last, and bring down the middle sign. Okay, if we do that, we're going to have x plus 2 quantity square equals 15. Okay, so this is the next step in solving the equation by completing the square. All right, the next problem has to do with translation. So question 4, describe the translation of the graph y equals x plus 1 quantity square plus 4 to the graph y equals x minus 2 square minus 5. Okay, so you can see here that this is a translation, so let's go ahead and describe the translation. Now, in order for us to accurately describe the translation, both the quantity of the move and the direction, we need to know where we're starting from and where we're stopping. Okay, so this is the starting quadratic, and then this is where you stop. Okay, so we have two parabolas that are being translated. So we need a common point on these two graphs. What is a point that we can easily determine just by looking at these two graphs that are identical? It is a vertex. Okay, so let's go ahead and write down the vertices of these two equations. So the vertex of the starting parabola is -1, 4. And then the vertex after the translation, where you stop at, the vertex is going to rest at 2, -5. So let's go ahead and, to describe the shift, what we'll do is give ourselves a visual so that we can carry out this counting accurately. Okay? All right, so let's go ahead and do that. I'm going to draw my coordinate system, and I'm going to graph the points, okay? All right, so the starting point is -1, 4, so -1, 1, 2, 3, 4. That's where you're starting from. And then you're stopping at 2, 5, 1, 2, 1, 2, 3, 4, 5. Okay, so that's where you stop. So how many units do you move left and down to get to the stopping point? So you're going to move, let's see, 1, 2, 3, 3 units to the right. And you're going to move a total of 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 units down, okay? So to describe the translation of the first graph to the second one, it's simply 3 units to the right and 9 units down. 9 units down. Okay, let's move on to the next problem. So for problem number 5, we're to write the given quadratic function in vertex form. Okay, so write the given quadratic in standard form. So let's say we have y equals x squared plus 6x minus 3. Okay? So to write this in, actually let's write it in vertex form, okay? Because it's already in standard form. Let's write this in vertex form. Okay, so how do we write this in vertex form? We just simply have to write it in the form y equals ax minus h squared plus k. All right? So we just have to make a perfect square somewhere here. So in order to accomplish that, we are going to create an incomplete square, and then we're going to complete it. So we have y equals x squared plus 6x plus that term that completes the square minus 3. Okay? So what completes the square? B is 6. So we divide it by 2, which is 3, and square it out, we get 9. Okay, so since we're adding a number to the right side, we have to subtract that number from the same side in order to preserve equality. Okay, so we add 9 here. Since we're on the same side, you do the opposite. Okay, if you're on the other side, you do the same thing. Okay, so this adding 9 and subtracting 9 from the same side gives you exactly the same problem you started with. So your answer is going to be y equals x plus 3 square, because you root the first and the last, and then you bring down the middle sign. Okay, and then minus 3 minus 9 is minus 12. So there goes your final answer. That's the vertex form of your quadratic function. All right, the next question has to do with conics. Problem number 6. We are to do the following. We're to find the radius, actually the center, find the center of a circle that well, let's say if the given points are on the circle. Okay, so find the center of a circle. We're looking for possible center of the circle if the given points are on the circle. Okay, so the given points are 2, 3, and 5, 0. Okay, so these are the choices we have here. Choice A, we have 2, 0. Choice B, we have 0, 2. Choice C, we have 2, negative 2. And then choice D, we have 2, 2. Okay, so given these 2 points on the circle, which of these could be a possible center of the circle? Okay, so let's go ahead and solve this problem. So the easy way to figure this out, we can just make a sketch, and then we can make a reasonable guess as to where the center is located. Okay, so let's go ahead and sketch the 2 points on the circle. So if you see, the 2 points are 2, 3. So 1, 2, 1, 2, 3. That's 1 point. And the next point is 5, 0, 2, 3, 4, 5. Okay? So these are the 2 points. And then you can guess what the circle looks like. The circle could open in this direction, or it could open in this direction right here. So let's go ahead and graph these other points and see which one could be the center of the circle. So we have 2, 0, 1, 2, 0. We have 2, negative 2, 2, negative 2. And then we have, so this is point A. This is point C. We have 0, 2, 0, 1, 2. That's point B. And then lastly, we have 2, 2, 2, 2 right here. Okay? So which of these could look like the center of a circle? Well, check this out. We can just extrapolate, okay? Let's make a circle that goes through these 2 points. How about I pick A? Can I make a perfect circle that goes through these 2 points? Oh, voila. You see that? You see how if you use A as a center, you have this nice circle that goes through those 2 points. Let's try another point. If we use this point right here, it's really hard, so that doesn't work. What if we try this point right here as a center? That doesn't really work. Let's try this point right here as a center. Not exactly. That point doesn't really work. Okay, so just by looking at it, these 2 points are equal distance from this point, and that's what a circle is. Okay, you need 2 points that are equidistant from a given point. All right, so we can clearly see that option A is our correct answer because it's basically 3 units from the 2 points. So our answer is option A, because that's the only option that can enable us to draw a nice circle through the 2 points where that given point resides right at the center. Remember, the goal is to find the center of the circle. All right, let's take a look at another problem on conic sections. This involves transformation. Problem number 7. So for problem 7, it says a conic in general form is given by, we know what the form of the equation of a conic in general form is, ax squared plus bx plus ax squared plus by squared plus cx plus dy plus dy plus e equals 0. Okay? Find the value of big B for the conic below. Okay, for the conic below. So let's say the conic that you have is x plus 2 square over 4 minus y plus 3 square over 5 equals 1. All right? So what kind of conic is this? We have 2 squares and a minus. That automatically makes it a hyperbola. So now this is the standard form of the equation of a hyperbola. So our goal is to change it into general form. Okay? So first thing we want to address is the denominators. We want to get rid of the denominators. To accomplish that, we'll simply multiply the equation, every term in this equation by the LCD of 4 and 5, which is 20. So multiply this by 20, multiply this term by 20, and this term by 20. Okay? 4 goes here 1, 4 goes here 5 times. 5 goes here once, 5 goes there 4 times. So we have 5 times x plus 2 quantity square minus y plus 3 quantity square times 4 equals 20. Now using the order of operations, we'll address the exponents first before we distribute. So x plus 2 squared, let's do that on the side here. X plus 2 squared is x plus 2 times x plus 2. All right, please do not interpret this as x squared plus 4. That's inaccurate, okay? So we multiply it by itself twice. If you expand this, you have x squared plus 2x plus 4. And your answer is going to be x squared plus 4x plus 4. That's the expanded form of x plus 2. So we have 5 times x squared plus 4x plus 4 minus 4. And then the same story here, the y plus 3. Let's figure out what that is. Y plus 3 quantity square is y plus 3 times y plus 3. If you expand that, you have y squared plus 3y plus 3y plus 9. Okay? And then if you combine like terms in the center, you have y squared plus 6y plus 9. So that goes in the center. So that gives us y plus 6y plus 9 equals 20. Now let's distribute 5 across these terms. We'll have 5x squared plus 20x plus 20. Distribute negative 4 here. We have negative 4y. That should be a square. Negative 4y squared minus 24y minus 36 equals 20. Okay? Now let's remember our goal is to set it equal to 0. So we have 5x squared. There's nothing to combine it with. Minus 4y squared. That's gone also. And then plus 20x minus 24y. And then we have plus 20 minus 36 is negative 16. And then when we subtract 20 from that is negative 36. So minus 36. Okay? Equals 0. Now this is the general form of the equation of a hyperbola. Okay? Coefficients are different. And we have 2 squares with a minus. Actually, just having 2 squares and a minus in between them is sufficient. All right, so we're looking for b. So what's the equivalent of b? Let's write the equation on top. We have ax squared um, plus bx, I'm sorry, plus by squared plus cx plus dy plus e equals 0. So what is b? We can see that b is the coefficient of y squared. So b is equal to -4. Okay? So that's that. Thanks so much for taking the time to watch this presentation. Feel free to subscribe to our channel for updates to other cool tutorials such as this. And do post questions you have in the comment section. We'll be glad to answer it. More clips can be found on markgoodserve.com. Thanks again for watching and have a wonderful day.